to talk a little more about limits and some rules for splitting them up and how they work. You will need to memorize the front and back of this first page of notes, so keep that in mind. And I'm going to talk about these briefly. You may need to study them yourself, or we can take questions tomorrow. But for an example, let's pretend that the limit as x approaches a is equal to, of f of x is equal to 4, and the limit as x approaches a of g of x is equal to 7, just for example purposes. So, law number 1 says, and 2 combined, if they are added or subtracted, they can be split up into 2 limits. So although we know very little about the sum of f of x and g of x, we do know the limit of f of x as x approaches a, which is 4, and we know the limit of g of x as x approaches a, so we know that this would be 11. We also know their values when we subtract, which would give us -3. The next rule says if we have a constant out front, we can move that out front. So this c value can be moved out front only if it is a constant, which means we would get c times 4 or 4c, because we are pretending that that value is equal to 4. Multiplication can also be broken up. So we don't know much about f and g multiplied, but we know the limit of f of x as x approaches a. We know the limit of g of x as x approaches a, so we know the value would be 28, because we are allowed to split a limit that way. Same with division. We know that this would be equal to 4/7. We know very little about those functions actually divided, but when broken up, we know stuff about each function individually. If we have a power, that power can be moved so that it contributes to the entire limit, not just what's in it. For example, the limit as x approaches a of f of x squared could be the same as the limit as x approaches a of f of x all squared, which means it would be 4 squared, or 16. Here's some standalone examples. If you are taking a limit of a constant as x approaches some number, you're going to get that number. A constant is a horizontal line. So approaching any values from the right and the left will be the same, and they will always be that same y value. Here's another one. The limit as x approaches 2 of x is going to be 2. Because on the line y equals x, those x values and y values are equal. So as we're approaching 2, we're going to be approaching a y value of 2. 9, the limit as x approaches a of x to the n equals a to the n, which means it's going to equal 2 cubed, or 8. Which is the same thing as plugging those values in, but we give you a rule for it. Is it absolutely necessary? No. Some of it you will know from yesterday's 3 steps. Step 1, plug it in. Step 2, do some algebra, and then plug it in. Or step 3, plug in values approaching that x value to see what the y value approaches. The limit, this is another one that we can just plug in, but they've gone to the point of making it a rule, so either way is fine. Number 11, the limit as x approaches a of radical f of x is the same thing as the radical of the limit as x approaches a of f of x. We're pretending that this, back to the beginning, equals 4, and the square root of 4 is 2. Those are your limit laws, all 11 of them. I know I flew through them. Feel free to rewind, look at them again, but those are the laws. From there, let's do a couple of examples. For example, we have pictures. F is the curved function. G is the, not indicated on here for some reason, but G is this function made up of the two straight lines. We don't know anything about f of x plus 5 times g of x, but we can break this up into the limit as x approaches negative 2 of f of x plus 5 times the limit as x approaches negative 2 of g of x. That 5 can come out front because it is a constant, and you can refer to rule 3 if you need to. When memorizing those rules, just understand them, know how to use them. You don't need to know what number they are. Back to this problem. The limit as x approaches negative 2 of f of x is equal to 1. Keep your 5. The limit as x approaches negative 2 on g of x is negative 1, so we get 1 plus negative 5, which is negative 4. Here's another example again. Multiplication. So based on our fourth limit law, we can break this up. This time, the limit as we approach 1 on g of x is equal to 2. The limit as we approach 1 on g of x, be careful, does not exist, therefore their product does not exist. Finally, this last example, we can break this up using limit law 5 into the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of g of x. The limit as we approach 2 in our picture on f is about 1.5. You're not sure where that came from, look at this value. We're approaching 2 from both directions, and it's approximately 1.5. Approaching 2 on g of x gives you 0. 1.5 divided by 0 is not possible, therefore the limit does not exist. In a second here, you're going to stop the video. Do examples 4 and 5 like we learned yesterday, those 3 steps. Try plugging it in first. If plugging it in doesn't work, do a little algebra, maybe factor, maybe reduce, something like that. See if you can plug the number in then, and if that still doesn't work, plug in numbers that approach those values. If you're approaching a 1, you're going to want to plug in 0.9, 0.99, 0.999, see where that is headed. You're also going to want to put in 1.1, 1.01, 1.001, and see what those are approaching. Both sides should be approaching the same value for the limit to exist. And we'll talk about the answers to those 2 examples in class tomorrow.